All right, good morning. So I'm going to kick things off here on this morning's live stream, picking up where we left off with the chess engine project. So I hope everyone is doing well. And I can quickly review some of the changes that I've made since the last time this was streamed. So let me get set up here. All right. Okay, so I believe where we left off last time, I had started working on Bitboard generation for the sliding pieces. So now sliding piece Bitboard generation, at least the first version is complete. So we can take a look at the current state of the notebook. I need to make sure that the notebook still works. And at some point here, I'd like to start writing unit tests for the code that we've already written for the Bitboards. Gotta get some tunes going here. Okay. Morning, Wesley Silva. All right, so let's see. So I did some renaming actually of some of the helpers. We can take a look at that in a little bit. Recap from last time's live stream, I have changed the way that we're doing the bitboards from using Numpy byte arrays to a single Numpy uint64 number, which simplifies things a bit and also keeps the data structure itself much smaller. Let's go ahead and clear the output here, start from scratch. And one of the nice things about this is using the uint64 data type from Numpy is that we can also perform bitwise operations directly on the number. Okay, so board still has a position and a piece map. And the print bitboard function is unchanged since last time. So we can see that the representation when we print this as a binary string is 64 digits binary, and this lets us see what squares are occupied. So right now we can see if we just OR the white pieces bitboard with the black pieces bitboard, effectively we get the occupied squares bitboard. Still need to generate the FEN, but now when we make a move which takes a piece, the square from and to, and then two placeholder parameters right now for whether or not it's a capture. And then I think the fourth parameter here is for castling. We can take a look at that in a little bit. And yeah, so you can see that the position is just a number. If we type this number, we can see that it's a Numpy uint64 type. And so we can pass this directly to our print bitboard function. Make another move, and we can see the bitboard is getting updated. So here's just a sample game, Spanish game. I believe I showed a lot of this last time. And at any point in the game with a position, we have a way to query the bitboard to show, say, the white pieces. I've also added bitboards to calculate attack squares, which we can do with bitwise operations. So for instance, we can just shift left 9 and shift left 7 to get the northwest and northeast attacks for current pawns. And so we can take a look at that, and then if we OR those together, we get both attacks at once. So we get the full attack for any given array of pawns. And then here I have set up static bitmaps for the attacks for the sliding pieces. And so at the start of the game, we just calculate the attack maps for every square for pieces that attack, sliding pieces that attack diagonally. So obviously the bishops. Um, these are sort of scratch notes, so we kind of start over here in a few places. Um, let's see. We'll come back to this. This was the code I started that's actually implemented now, and we can take a look at that. This is for generating the diagonal attack bitboards from a particular square. So that's the bishop. We have a way to calculate the rook attacks, and then the queen attacks is just the logical OR of the bishop and the rook. And so we can see if a queen was here on d4, these are the squares that the queen would attack. Now if we, this is sliding piece motion on an otherwise empty board. If we want to get like the first piece that a queen would attack in this case, let's take a simpler example. If we want to get the first piece that a rook would attack, so we have a rook on c4, and let's say that we have a piece on c7. The way that this would work is however we're representing the intersecting piece. So let's say that we want to intersect this with a black occupancy bitmap, and this is a white rook attack bitmap from c4. What we would do is we could take the logical AND of the rook attack bitmap and the black occupancy squares. That would give us one hot on c7 and one hot on c8. And then we can bit scan left, or bit scan forward, if you will, until we hit the first hot bit. And for any direction in which we're going in a positive direction, the intersection of that and the bit scan, actually just the bit scan itself, gives us the location. And then we do a bit scan reverse if we want to get the location for a piece that's in the negative direction from the attack. And I created another notebook for that in Scratch Notes, and was able to take an algorithm from Eugene Nalimov for the reverse bit scan. So basically we have this lookup table for the reverse bit scan. We have the king attacks as well, and you can see that I've handled the wrapping at this point. So if we have a king on h8, then we attack g8, h6, or h7 rather, in g7. We also have the knight attacks bitboard, so this should all be available. If, for instance, let's look at the knights really quickly just to make sure that's still working. So let's say we can keep it from d4. Let's say that, let me move my big head out of the way here. All right, so we have a square d4 in the attack bitboard. We can get the knight attacks as well. So we should get the knight attack bitboards. Hopefully this still works. If it doesn't, that'll be the first thing we can work on this morning. Yeah, this works. So we see the knight attacks. This should no longer wrap as well. So if we get a knight attack from a1. Okay, so the knight attack is wrapping, so we'll need to fix this code here. e2, so we have wrapping from a to h here, so that can be fixed. About on the h8 square, we're also seeing wrapping. So we're seeing wrapping on the h and the a files. So this will be a bug that we can fix this morning. But for the center of the board, anyway, the knight should be working pretty well. Okay, so let's take a look at some code. Also, if anyone wants to play chess this morning, I'll keep Elite Chess open. Just feel free to challenge me at Westman. Or chess.com at westwill. Alright, so let's try to fix this bug with the knight bitmaps. Let's So the Bitboard helpers actually now has most of the code for the pre-generation of all of the bitmaps, whereas the board, for those static bitmaps, it just initializes them and sets them as adders on the instance. So I think the idea is that we basically keep a board for the duration of the game, and the game, which I still haven't gotten to yet much, is still going to be not a stack of positions, but we're going to represent it as a stack of FENs, I think. And then from any given FEN, we can rebuild the position. Because the FEN contains, I think the FEN contains enough information because it contains the position of the pieces, but it also contains castling rights on passant target squares and half move clock, I think. So how many moves there have been since, I don't know if it's since the last irreversible move, but I think FENs contain enough state for us to rebuild any given position and play the game. So, all right, so let's fix these knights. Every time the position is updated, basically currently this is not very efficient, but we're storing the piece. So the bitmaps just give us what squares a particular class of piece are on, or any logical thing that can be any logical combination of other bitboards. So we can get things like the logical OR of the white pieces and the black pieces and get the occupied squares. We could take the complement of that to get the empty squares. So the piece map gives us information about specifically what pieces are on what squares. And so that gets fed from position into the board object to actually update all those bitboards. So that's what that big function is. Sliding piece movement. We need to get the knight movements. All right, so basically what I'm doing is saying get knight attack from. This is actually when we want to do the lookup of the knight attacks. The lookup is nice because it's constant time, and we have already pre-calculated all of the knight attack bitboards at the start of the game, so we don't do that every time we need to update. But we need to populate knight attack bitboards somewhere, which is in this make knight attack bitboards function. And so we have an attack map, which is a Python dictionary, and then for all of the board squares, we set the index at generate the knight attack bitboard from that particular square. And we start with an empty bitmap, and then for I in all of the directions relative to the current square that a knight can jump to, we set that bit to 1. But what I'm not doing here anywhere is masking off the A or the H file. So let's go ahead and drop this back into Jupyter Notebook, and we'll fix this. So generate attack from square. We'll set this up. And the way this is working is we are ORing in place. So I ORing the attack bitboard with the square plus I, which is just again relative to the current square that the knight is on. So the knight plus 6, which would be north. I always get this mixed up. So that would be northeast. All right, so I plus 6 would be this. So east, northeast, northeast. And then 10 would be here, west, northwest, etc. So, and then 0 obviously where the knight's on. So let's go ahead and see if we can do this. Generate knight bitmap from square. So that's the knight bitmap. And then we'll just pre-print this. You can see it's just a number. And if we were to generate the binary representation of this number, that helps illustrate it a little bit better as well. So print binary. I have a helper method for this, helper function. Get binary string. So we can take a look at that as well. And so you can see that's just a representation of the occupied squares that this particular night is on. So that's hopefully illustrating why the 64-bit, in this case, unsigned 64-bit integer with Numpy is a great data structure, I think, to use for this purpose. In case anyone's wondering, the Numpy uint64 data type under the hood is let's see, is a uint64t in C, which, as far as I understand it, should be represented in exactly n bits. When we get the size of it in memory, I think the minimum size of a Numpy scalar is still going to be 32 bytes, I believe. If we do sys.getSize of mp.uint64.0, so it's still going to be 32 bytes minimum size. But that's much smaller than, say, like an MP array of an initial value here, where this would be what we had originally, which was a byte. So it's going to be like a third of the size, a little bit more maybe. And uint64 here is going to be much larger if it was an array of uint64s. So I guess it's good to keep an eye on that kind of stuff. All right, so let's try to fix this bug. Basically what we need to do is we need to mask off the H and G file or the A and B file depending on the current square of the night. And we should be able to do that with an with the AND complement, right? Okay, so we can say if square in file.hex A. So basically, hex A is the hex representation of the, it actually looks nicer in hex. Maybe it's easiest to understand as if we just print it. So there's the A file, and then there's the H file. So what we need to do is file.hexg. We need to create a mask like this for when the night is on the A file. If it's on the B file, we just need to mask off the H. But we can keep them, it doesn't really matter, we can actually keep the mask as both in either case. It's just explicitly dependent on which file the night is on, because the night can wrap at most 2 squares. You can see if it goes east in any direction 2 squares, and that's where it's going to wrap. All right, so let's see. I should say that's the furthest it's going to wrap. So if our square is in file hex A or file.hex B, actually, I wonder if we just do this first. So we get the attack bitboard, which we know wraps. And then if the square is in file.hex A or hex B, we and the attack bitboard with the complement of hex H and hex G. the union of hex H and hex G. I'm kind of winging this. Okay, argument of type int is not iterable if square in oh, I see. I will be right back as well. Be back in just a moment. Okay. So the problem is I can't look in these. These are just numbers, and so rather than that, what I can actually use is if square in file dot a. Actually, I think it's file dot. Let's just take a look at the code really quickly. Constants. Yeah, so file.a is going to be the set of those numbers. So we can say if, I realize that this is not the most efficient, but it's a set lookup, so that should be constant time. But we say if square in file.a, then the attack bitboard is going to be IOR'd with the current attack bitboard and the complement of the G file and the H file. Can I do this actually? Okay, should be able to maybe do that. And then for the square here, let's inch closer. All right, so now if we go B4. Okay, so this actually doesn't work yet. Oh, we need to do if square in file A, or how do you union sets in, I think it's just file A or file B. File B is not defined. Okay, so let's make sure that we're getting in here. Should mask. So we're not getting in here. Let's just test it here. All right, so let's take a look at what file B is coming up as. So that's this. Print square, print file B. So that oh, because I'm doing list of file B. All right, should mask bitwise or not supported for the input types, and this is because square needs to be a Numpy uint64. Otherwise, it's getting interpreted as the Python native type or whatever, which is float. Bitwise or not supported for these input types. Really? All right, so this is coming in when we call set bit. So attack bitboard. Oh, sorry about this. np.uint64 on the iterator as well. Hey, Sidhant, good to see you again. All right, so what are we ORing here that can't be ORed? Bitwise OR not supported for the input type. So this normally happens like if you try to do a bitwise OR with a Numpy data type and a Python data type. So let's figure this out. First of all, all right, so that works. So attack bitboard, IOR set bit attack bitboard. np-uint64 square plus, oh, this addition operator is probably what's causing it, so we can just do this instead, I believe. All right, so now we get this error. Set bit attack bitboard np.uint64 square plus I. So let's give this a shot. So if we call np.uint64 on square, we do get 25. If I do square plus this and then do type, obviously that's a Numpy uint64. The arguments to set bit in the correct order. Let's take a look in the code. So set bit takes in the bitboard and the bit. Even if the bit doesn't come in as a Numpy uint64, if bitboard doesn't come in as a uint64 though, that's another issue. But this is used all over the place, so I'm still uncertain as to why this wouldn't work. Let's go ahead and at least for a sanity check do this. So now I'll just restart the kernel and run up to this point. Yeah, I still have an issue here. So for I in every square, let's just do this, uint64i. Hey Taylor, long time no talk, long time no see. And hello Spark Arts. All right, so kind of in the weeds here a little bit. I feel like square plus I should always be, maybe I should change the constants. Maybe I should change the squares here as well to always be Numpy UN64s. They should still behave the same everywhere. And that was a vim fail. All right, we're going to redo that. All right, all 64 squares. Yeah, long time no see for everyone. That is very true. All right. I hope that doesn't break anything. I mean, it's just changing the type to be a Numpy uint instead of a Python native int. Also pretty interested in seeing what the size difference is between a name uint64 not defined where. Oh, because I did np. I think I have a shortcut in this notebook to do it this way anyway. U is not defined. I thought I did, but I don't. We'll do it this way. One thing I dislike about Jupyter is that for some reason occasionally the bottom line gets obfuscated by the scroll bar, the horizontal scroll. We'll just do it this way. Import np.uint64 as u. Numpy.uint64 as u. Really? I thought I did this. I do this in my scratch notes. From Numpy import uint64 as u. Sorry about that. Should mask. And now we're still getting this bitwise OR not supported. But I'm ORing. Am I not ORing? What happens if we print type of attack bitboard? Int. Also, what am I? Should mask, and then it's printing int. So the attack bitboard is coming back. There we go. All right, sweet. We did get a warning about scalars. The problem was when I was equaling the complement of the G and the H files, that result was coming back as a Python int. What's up, Alvaro? Good to see you again. I'm doing all right. The last stream wasn't the best because I was pretty sleepy and just making a lot of bugs, but we're making progress now. All right, so we've successfully masked off this square. Overflow encountered in ulong scalars. All right, we should be able to clean that up. Should I just return, should I change hex G to actually be the uint representation instead of the hex values as well? I feel like I should do the alias in the source code as well, not just the notebooks. But it feels a little hacky, so I'm just going to keep the numpy. All right, so let's get rid of this print. So we're still getting an overflow in ulong scalars attack bitboard, I or set bit attack bitboard square plus I. I wonder how we could be overflowing ulong scalars. Ulong, I suppose, is a UN64. And this is an IPython error. So this is, I don't know if that means that it's coming from Jupyter Notebook explicitly, or if this is a Python or a Numpy thing. Oh, it's because one of the values might be negative? Oh yeah, duh. If I try to convert minus 17 to a, we shouldn't need to do this, I think. If the square is negative, yeah, all right. So I don't need to try to turn a signed number and a negative number into an unsigned int, and it gets handled downstream when things happen. All right, so we've masked off the H file in this case and the G file when we're on file B. We can do or square in file A as well. And I think this can be simplified, forgive me if I'm wrong about this, by doing this. Now we're doing an actual Python set or, and not the bitwise or, although it's probably a bitwise or under the hood maybe. But it's this or is just saying or file A and file B, which are currently represented as Python sets. All right, so while I'm at it, I might as well numpify all of these types as well. The ranks, I can't remember if I'm iterating over these anywhere, otherwise I'd make them a set probably. The pieces are only used as sort of like an enum, so they don't really need to be represented as anything but unique values, so we don't need to worry about the type there. Okay, if this works, then we need to mask off the, let's just make sure this works for the A file. So let's choose another square, A8. All right, cool. So let's mask off the A and the B files if the square is on the G or the H. So we can do it this way, because this should still wrap if we're on like the G file. And it does, so let's see if we can fix that by saying if the square is on G or H. Attack bitboard is the getting ANDORed with the complement of the A and the B files. Now we have a full night bitboard. So let's just double check if we're on the H. All right, and if we're on H5. So it looks pretty clean. I can check A5. All right, cool. So what I'm going to do is update our generate night bitboards here for I and range squares, generate the night attacks. Well, Numpy's slow. Maybe it, or Numpy, PyCharm is a bit slow this morning. Maybe it's because the stream running low on memory. All right, we're gonna stop some of the Jupyter notebooks as well. Let's shut those down. And I'm gonna close Discord. Sorry if anyone's in there, probably not. And then close some of these tabs. Alright, so this got completely updated. Generate knight attack, bitboard from square. And we just got to change this to np.un64. You would think by now my muscle memory for typing np.un64 would be better, but it's still a very awkward string to type. Okay, so for each I in these, we set the attack bitboard and set a bit hot at the attack square, and then if the square is A or B, then we mask it off. Probably we can do that in one operation. We probably don't have to have these if clauses, but I'm going to leave them there for now. Mask off, wrapping. Alright, I'm going to take a 5-minute break to play a game of chess. I also implemented the knight moves, or sorry, the pawn moves, so we can make sure that those are working as well. Yeah, however, I do have a Discord. I'm not super active in it, but I'll see if I can find the link here. Alright, I don't think I've ever seen this move, bishop d3. So I wonder if I just keep playing normally. Like normally here on the previous move, white plays knight g3. So I'm gonna just play as if they had played knight g3 and see what happens. Hey, what's up, Hari? I should have posted the link to the Discord in the description. Alright, so this is a really weird Caro-Kann. I feel like I should be able to get something going here. But I don't think I've ever seen this position before. Alright, so if I play knight f6, if he wants to trade that knight off, then takes, and I could at least trade off his bishop. Which language is it, Hari? Version 1 is in Python. And as soon as this 5-minute game is over, we'll go back. And what I'm going to do this morning is the pseudo legal move checker, or whatever it's called. Basically, we check all the legal moves. It's called pseudo legal, I think. Chess programming, because we check everything except whether or not it leaves the king in check. Pseudo legal move. Pseudo legality test. So this will be what we check next. Alright, I'm going to lose on time if I don't focus. I don't want to simplify the position yet. Normally the queen goes to c7 or b6 in the Caro-Kann, but I've never played something quite like this. I guess I'm just trying to keep the tension here. And I'm going to go ahead and castle over on the queen side. Now if he wants to take on f6, I'll take with the bishop, and then I at least have tempo. And so he's going to start the attack here. Maybe he'll even sack the bishop if I play a6. What's my idea? Alright, I'm going to trade off this knight, trade off this bishop, and make the attack on my queen side a little bit less scary. And maybe I can start rerouting the knight to a better square in the meantime. Okay. Just try to blunt this attack. He'll probably play b4. And he does. I gotta play faster. I gotta play faster and play better. Oh, alright. Let's try to just get out alive at this point. And I think I'm gonna try to walk my king back. And he wins the pawn on a6 and basically is crushing now, I think. He doesn't go for the... Oh, he's trying to mate now. I don't think I even have a way out. So what can be done? Oh, this is ugly. This is ugly. Alright. I'll play one more. Alright. Hopefully I'll play a little bit better this time. I should go back and look at what I should have done. So playing Italian, we'll try for the fried liver attack, which we never really get. Normally they just play knight a5 here. Opponent thinking. Yeah, knight a5 played. And then normally the bishop, I think, comes back to d3 or e2. After takes. I gotta start playing d3 here instead of always trying to go for knight g5. I'll be interested after sort of finishing the Bitboard stuff to take a look at the mailbox implementations like OX88. But I feel like the Bitboard's pretty nice. So maybe the bishop is supposed to come back to d3 so that I can play knight e4 here. Because here what happens is knight f3, e4, and then what? The knight just has to come all the way back. I suppose. Oh man, mouse slip. I meant to play knight f3, so that's just hanging a piece. Wow, really on fire this morning. Alright. So let's get back to the code, and maybe now that the bitboards are more or less complete, we should be able to check whether or not it moves legal. So let's figure that out. We can come all the way back up into the position, and in the make move function, we can now populate this is legal move, and we'll do this pseudo legal move check, I guess it's called. This could be a hash move probed from the transposition table or a killer move supplied by the killer heuristic. In cut nodes, one may save the complete move generation by one legality test. All right, so what's a killer move? A quiet move, man, there's like so much jargon. A quiet move are all moves which do not alter material, thus no captures nor promotions. One can also exclude moves that present imminent threats, such as check. Sort of a similar meaning to the when people say quiet move when kibitzing. Killer move is a quiet move which caused a beta cutoff. All right. I'm not even at the search part yet. So we're going to start simple. In my mind, a legal move can be checked by checking whether or not the moved piece intersects with its legal squares to move bitboard. So it's attack bitboard with everything except for the pawn, which has move bitboards, which are distinct from its attack bitboards. So let's bring move in here. And this returns a Boolean. And so in my mind, what we need to do here is to say, Alvaro, you need to, yeah, me too. I'm going to go with what's intuitive here, which is obviously not going to be the most well thought out or computationally efficient. It's worked out so far to get things basically working. All right, so is legal move, my idea here is to get position of piece from the piece map. Have I excluded from the attack bitboard the player's own pieces? No, not yet. But I figured that would be done at move making time, and the way that would work is taking the bitwise and of the of own pieces. Let's see if this is the right notebook. So in the last stream, I talked about this Nalimov algorithm for reverse bit scanning, which works for the negative direction, and forward bit scanning, which is a lot easier, which just scans until we see a bit going forward. I'll close this notebook. It's not in this one. Maybe it's in this one. And so at least for sliding attacks, the way that it's going to work is we just bit scan until we hit the first hot bit. If that's part of the set of the opponent pieces, then that square is an attacked square. And if the intersection is with your own pieces, then that's just a blocking piece. But we have to do that, I think, at move time, I think. Can't remember which notebook Nalimov is in. Must be in Scratch Notes then. I think Jupyter's a pretty serious memory hog. Yeah, and then our bit scan forward, I hope that here's the bit scan forward algorithm. So just shift right until the value mod 2 is equal to 0. So if we're on C4, this is basically going forward through the array until, in this case, we hit 49. and the intersection is the attack bitboard plus the occupied. So here was the attack bitboard, and the occupied was B7 and B8. So if we just get the intersection, we don't see what piece is attacked strictly from the resulting bitmap, because in this case we get everything that it intersects with. But then if we bit scan from the position of the rook in this case, the first square that we hit is 49, which in this case is B7. So, and then to do a reverse direction, so here we have occupied squares on G1 and G3. I must have gotten rid of the rest of the notes, but basically we bit scan backwards, and I had trouble wrapping my head around that, but when I was looking around, I saw that Eugene Nalimov has an algorithm for it. And so when we bit scan backwards, we run into, in this case, G3 if we had a rook on any square on the G file here, north of G3. All right, so let's head back here and let's think about the legal move. So my idea is intuitively, I guess, I feel like the legal moves are going to be get the position of the piece from the piece map. And then to Alvaro's point here, we need to check the blocking squares. So we're going to need to do our bit scans here for sliding pieces. Basically, if it's a knight, we just look up if move.2 is in the move.2 intersects with the knight attack bitboard. Same for the case in the king. So if it's a king, move intersects with the and I'm just gonna do some shorthand here. If it's a sliding piece, look up if move.2 intersects with the So actually this is interesting because it's all the moves up until the value that the bit scan finds if it's own pieces, and it's all the values including the piece that the bit scan finds if it's opponent's pieces. And in the latter case, it's also a capture. So sliding pieces are actually pretty complex, I guess, because it's like, look up if move.2 intersects with the following. It's if own pieces square up to but not including the bit scanned find in the ray direction. So if own square up to but not including if opponent square up to including the bit scan find in the ray direction, this is a capture. And we still have the clause that it's a capture in any case if the intersection with the opponent bitboard, the opposing color bitboard, is hot. So for those squares, we label those as captures as well. Okay, I think the knight is the easiest piece to do this for. The pawns are a little bit more complex as well because they have two disjoint bitboards in the motion and the attack, and they also have to take into account an en passant target square. Also, kings are complicated in the case of castling, but it's all just simple rule based, so we should be able to work it out. Let's do the knight because I feel like that's the easiest. Okay, so if move dot piece, and how am I going to find out explicitly what piece? It doesn't matter, it's just the piece type. So what's the type of a piece here? I think if move piece is equal to piece.knight, SparkArt says it's difficult to explain chess to a computer. It is. I certainly don't know how to do it. I'm trying. What depth do I want to go to? Right now I want to go to depth 1. But I haven't really started thinking about search yet. Abra saying, I thought I would ignore the bitboard of the pieces of the player's color with the attack bitboard, but that would only work with knights as you have no ray notion, I guess. Yeah. We have to include all the squares up to in the direction of the ray for the sliding pieces. But I shared your initial intuition. So right now we're saying if the move piece is a knight, we need to find if the current position, which we have a board on, if self.position, all right, so let's get the current square. Current square is move dot from square. Okay. The current square is the move dot from square. We want to say if it's a knight, I'll put in all these helper functions later to make it a little bit more interpretable. Also, the music I'm listening to is a little bit too intense. Okay, so if the piece is a knight, what we want to say is look up if move dot 2 is intersected with the knight attack bitboard. Legal knight moves is going to be equal to board dot, sorry, positions have a board, so self dot board dot knight attack bitboards. We can say get knight attack from current square. And why is this a function? Let's move this into the position for the time being until I can pull it back out if possible. But we'll make it an instance method for the time being. And so we'll make this self. All right, so if it's a knight, the legal knight moves are a lookup from the knight attack map from the current square. And immediately what I should be able to say is if, and legal knight moves comes back as a set, I think. Knight attack, bitboards, make attacks. We're saying knight attack map at a particular index is, so this actually comes back as a bitboard. Okay, so the legal night moves comes back as a bitboard. And now we need to intersect legal night moves with the 2 square, with a bitboard that has 1 hot on the 2 square. If not that, it's not a legal move. So this is a bitboard. This is why I need a typed language. Okay, if not legal night moves and set bit. How does this work? Bitboard bit. This is super inefficient, but for the moment, what I'm going to do is this. Man, my hands are cold. It's snowing here. We got a bunch of snow. And it's pretty cold out. Alright, so if not legal night moves and set bit on bitboard and then the square. So we'll say bb piece.2, move.2. And does bit always get cast? It does. Alright. If not legal night moves and set bit 19 square, turn false. So what we're saying is if it's a night, the legal night move should be any square, although we haven't intersected with the own or other pieces yet, which will tell us whether or not it's actually a legal move or a capture. So in this naive implementation, this is just saying, is the move you're trying to move to part of the knight's attack map from that particular square? If it's not in the attack map, in any case, it's always false. If what we want to do next is like a clause that's like this, if intersects with own pieces, return false. Tycoon Gaming, I was just making a joke because I don't have any, right now my chess engine is depth 0 technically because it doesn't move. I don't have search. So step 1 is just to get that working. Right now board representation is version 1 is finished, and now we're working on move generation, and specifically I'm working on determining whether or not a move is legal. Once that's done, then we can work on search and a few other small things to take care of in between there, like FEN generation and maybe a board representation, a new pretty print that doesn't print bitboards but prints the piece maps would be nice, so we could actually see the position. And we could use the UTF-8 chess glyphs for that. So if not legal night moves and the bit representation of the square we're trying to move to, if that doesn't intersect, we return false. If it intersects with own pieces, return false. And what we also want to do is say if it intersects with opponent pieces, return true, and is capture, sets to true. So do we just mutate the move? Because the move comes in, I think, with whether or not it's a capture. So I'm gonna go with that until it doesn't make sense, but at the moment it makes some sense, I think. So if intersects with own pieces, let's make that method. So we have own pieces on the bitboard. So if self.toMove is color.black. I realize that this could a lot of these ifs could just be dictionary lookups. I'll work on all of the little efficiencies like that later. But if we're black, then let's do this. Hey Hemant, good to see you again. Alright, so own pieces is none. I'll fix this in a minute. If self.toMove is color black, own pieces is equal to, yeah, we'll replace this with a dictionary lookup. Own pieces is self.board dot, we need white pieces bitboard. So what I really want to do is say occupy lookup is equal to this, and color.black is equal to self.board.white pieces bitboard. Sorry. Color.white is self.pieces.white. So we know this a square intersects with its own pieces if I gotta figure out a better way to get a bitboard for a particular, like an empty bitboard with just the move hot. So for now, it's always looking like this. I should just write a helper function for this. Set bit move square bitboard is equal to set bit bitboard square. So now we have this, and we say intersects with own pieces if occupy lookup at self.board.side-to-move, or I think it's just self.current. What is it? Self.toMove. Intersects I don't have that Vim key mapping Hemath, as far as I'm aware. So if occupy self.toMove and move square bb, we return true. Alright, so this should tell us if we intersect with our own pieces by saying, alright, here's the bitboard representing the square that we're trying to move to, which should just be one hot bit in that location. We look up whether we're playing with the black or white pieces, and we intersect that with a move square bitboard. I guess that's about as fast as we can do it. We would also have intersects with, I wonder if I should alias this with attacks, like is capture, basically. Is capture. one part of me wants to keep it consistent with the intersects with prefix, but every time we intersect with an opponent piece, it's always a capture, right? Or a check. So maybe I should have the abstraction of saying intersects with opponent pieces, because there's a distinction between a check and a capture. But technically, that just means the king is in check, and I mean, technically it would be captured, so it is a potential capture. I'm going to keep it as is capture. Is there another case where that wouldn't work? Yeah, if a piece is defended, it's not a capture. So I'm gonna stick with intersects with opponent pieces. And basically occupy lookup, and now we want to say that if we just want to flip this, right? So we flip the keys and say if we're white and we intersect with black, we return true, and if we're black, we intersect with white and we're true. All right, cool. So I think we can reuse this function here, this method. So we'll say if not in the static attack map, if it's not in the static attack map, return false. If not, self dot if self dot intersects with own pieces for the current square. No, this is the move.to square. Return false. If it intersects with the opponent pieces, return true, and it is a capture. That's not always true. Move generation is harder than it seems, because it's not necessarily a capture. Is capture also depends on whether or not that piece is no, wait, what am I saying? It's just the king that's tricky. So like, let's say we have, let's pull up the board. So analysis board. All right, so in this position, 95 intersects with black's pieces. It's the intersection of the knight attack map from F3 and the black occupancy map. Doesn't matter whether or not the square is defended, it's still a legal capture unless you're a king. So first of all, the king can't even move to this particular square. Let's move this back here. All right, so now the point is, here's where it's tricky. So for the king piece, even though the king's attack map intersects with the black pawn here, the pawn's defended, and so it's technically not a capture. But I guess that's sort of the point of the pseudo legal moves, is that the pseudo legal move is legal in the sense that it's consistent with the board representation, and it must be a member of all pseudo legal generated moves for that position inside to move. So wordy. Also, I'm gonna make this a little bit easier to view. Don't I have some plugin where I can actually make this a little bit easier to view? Apparently not. Let's see. Inspect. Yeah, Alvaro, I agree. King and en passant are the tricky ones. Also, I wish that this text wrapped properly. So basically, we don't worry about whether or not pseudo moves may still be illegal if they leave the own king in check. Most often the king was already in check before, or the moving piece was absolutely pinned. Yeah, so a pin is when a piece can't move, because if it were to move, it would reveal check on its own king. So we could pin, like, let's just create a pin here. Let's play like this, and then this. Now it's black to move, but it can't move the knight because it would reveal check on the king. So with the pseudo-legal move check, we still say that the pseudo-legal moves for the knight are everything on the knight attack map that doesn't intersect with self or other position. Even though it is technically illegal, that check is done subsequent to that generation to simplify things. So basically, it's sort of like, yeah, this is legal, and then you check to see whether or not own side self king in check, and then you realize that it's illegal. Okay. So let's say then with our pseudo-legal generation, then it still technically registers as what we can call a capture, even if it's not a legal move, which gets subsequently checked by the king state. So if self dot intersects with opponent pieces, move to square, we're going to return true. I feel like I should have a failsafe here just to say it's not legal. So this handles knights, which don't have any special considerations. They always just land on whatever square they can land on. We've already taken care of wrapping and all of that. What's the next easiest piece? Pawns, I guess. Do I even need the current square? Yes. I should just pass the whole move. Wait, you can go to empty squares? Yeah, you can go to empty squares. I need to include that as well. So maybe the failsafe should just be return true, which represents empty squares. Good call, Alvaro. If that's not the case, I'll think through it in a second. But first, I guess I should just pass the whole move to this. So we can say pass move, bitboard. Yeah, good call about default false. I think it should be default true, and we'll consider that the empty squares case. So we'll just pass move. We'll pass bitboard in move dot from square. We'll pass in the bitboard. And then this clause here is to do we can just mutate the move, I think, in place. This is probably nasty. Is captures true? That's probably gonna come back to be a bug and haunt me when I figure out why moves are mutating in place like that. So we should be able to play with the night move shortly now, at least the simplified version of it. If move.piece in piece dot white pawn, piece dot black pawn, turn self dot is legal pawn move. And the pawn moves are separated by color, obviously, because it's still a static bitmap, but it's a static bitmap for white and for black. So like for knights, whether you're a white or a black knight, the legal squares you can move to are always the same, but a black pawn on c6 or a white pawn on c6 move in opposite directions. So, and attack in opposite directions as well. So pawns are slightly more complex, but perhaps as I'm thinking about it, the next most complex, because sliding pieces have this bit scan operation which we set up, but I just need to think through. So if it's a legal pawn move, we can go ahead and create this method now. So again, we'll have a dictionary lookup here, similar to what we did for the intersects with self and own. So pawn move is going to be legal moves. We'll make a dictionary depending on the color. So this will be color.white is self.board.white pawn motion bitboards. Glad I made all the bitboards up front before I started trying to do move generation. Hey Arjav, what's up? Aryav, I apologize if I said the name incorrectly. Black pawn motion BBs. And then this is actually pretty simple. All of the complexity in the pawn moves, which is really just whether or not it's on its starting square or not. So obviously legal pawn moves here are these two squares. Legal pawn moves from any other square are just one. And that's taken care of at the start of the game when we generate the static bitboards for pawn motion. So what I can do is, I feel like all these places where I'm creating a bitboard just to use for the purposes of Did I not set this? I need to set one hot or set a bit on this square here. I feel like I want to do this way before. That's okay. Yeah, good call, Alvaro. So in the last stream, I did that in the board class. So when we make the white pawn attack bitboards, what I do is I say for all the squares that a pawn can be on, generate the white pawn attacks from that square, and then I thought I did. Oh, this is the attack. Sorry, let's go to the position, the pawn motion. Yeah, so we say if the square's on the second rank here, then we say the legal moves are the next 2 rows up. So I or that with moving up 1 to I oring that with moving up 2 as well. So that's taken care of at the start of the game. So that's just a constant time lookup now. So let's go back here. So that's encapsulated in this legal moves bitboards. So return legal moves at self dot to move with the move square BB. All right, sweet. So I hope to move as well as the color as well. Yeah, okay, that's good. All right, the other legal pawn moves are captures. So we need to OR this with the captures. This is going to be legal non-capture moves. And then we're going to say legal capture moves. I'm actually really loving working with bitboards now because of the fact that we can use set arithmetic everywhere. Okay, so and the attack bitboards are also generated ahead of time, so we can say here did I just not call that BBs on the other one? I did. Why can't it find that? Oh, it's a typo. Okay. Yeah, yeah, that's true. I guess it's technically the or of those two is the like the union of those two, but yeah, exactly. Alright, so legal attack moves. Return legal captured to moves and square bitboard. Here we should be able to say or legal attack moves. And here I can simplify all of this actually just by saying legal moves is equal to legal non-attack moves or legal attack moves. Nice. So the move square bitboard is the square we're trying to move to, and if that intersects with our legal moves, we're saying it's legal. And legal moves are... Did I just do this twice, or what did I do here? Non-attack moves. Okay. Alvaro, you're catching all my bugs, so I owe you some bug catches now and then. Also, yeah, I already made the BB here, so I'll just remove it from here. I don't think this method really needs any comments. It's pretty clear what it's doing, so I guess that's okay. And we already did this. All right, I'm gonna push these changes. Jupyter Notebook diffs are hard to scroll through. It's cool that they're represented as JSON though. I don't really care about the Jupyter Notebook changes for the last little bit of code that we've been working on. So this all changed to use Numpy unsigned ints. Same for the hex number representations of the ranks and files. Yeah, we'll be storing the game as a stack of FENs until I realize that there's something wrong with that approach. IsLegalMove became an instance method. We now have helpers for intersects with own pieces and opponent pieces. All this needs to be tested. And isLegal pawn moves. Okay. So work on move generation. Pseudo legal move generation. Alright, so that should be pushed to main. If you guys want to see the code for this for yourself, you can check it out over at the GitHub. And the notebook should render as well. Yeah. I should put doc strings on everything, I suppose, Alvaro. All right. Yeah, I think after I get the pseudo-legal move generator set up, there's two things I could think to do. One would be to work on the castling rules and en passant, which is not part of the pawn legal moves yet. That should be easy though. Basically, the way that that's going to work is the en passant target square is set on the position object, and all I need to do is to OR the pawn legal moves with the en passant target square. If it doesn't exist, then it doesn't OR with anything, and if it does exist, then it's a legal move. So actually why not just do that now? That's like super easy, right? I think it makes sense. En passant, how do I spell that? En passant move. is going to be the other thing is I feel like I want to sort of memoize all of the, or cache or whatever you want to call it. I want to set all of the legal moves that are possible. Not sort of when queried, I just want to query all of the legal moves in the position and set that on the position object. Obviously, we'd have to do that. I think that's where search starts, right? Okay, but an en passant move is basically en passant move is going to be the legal attack moves for self dot to move. Oh, and there's a bug here too. Legal attack moves is only the attack squares that a pawn can, and it's not legal unless there's an opponent piece intersecting with the attack moves we have here. So I'll fix that bug for a second. In a second, but en passant moves are going to be legal attack moves on the side to move when intersected with self.position.en passant target, self.en passant target. And this needs to be a bitboard, so en passant bb is set bit. On an empty bitboard. En passant move is this. Or en passant move. And this is not self. Okay, so that cleans that up. Legal attack moves is not finished yet though. This is like all potential legal attack moves, but what we need to do is legal attack moves or with the other side's position. So opponent occupied is going to be dependent on the current color, so color.white is going to be self.board.black occupied squares. What did I call this? Black pieces bitboard. Yeah, the more I sort of see the use cases for bitboards, the more happy I am that they exist, because we don't have to do any loops anywhere. It's just these set operations. It's like pretty semantic, I feel like. So self white pieces bitboard. Which is the intersection of white pawns, white rooks, white knights. The other thing I did is I set these all as Python properties for the bitboard access. These are the dynamic bitboards that get updated basically, and so this way that we have like getters on them, and they can be computed on the fly, but they can be queried as if they're just regular attributes. Okay, now I lost my place. Opponents occupied. So legal attack moves, we need to IOR with opponents occupied. All right. That's too much code to write without testing. So legal moves for pawns are any non-attack move we need to make sure that we're not intersecting now with pieces. Did we do that for the night? Yeah, the properties are new from last time, but they do, I think it's a good use case for them. For is legal night move, I check whether or not it intersects with own pieces. I gotta do a lot of refactoring here. Legal non-attack moves are gonna be this. And then but I need to make sure if it doesn't intersect with its own piece or intersects with. All right, so we're gonna make another one here. Intersects with any piece. This is gonna return intersects with opponent pieces at square or self.intersects with own pieces square. And actually this could be simplified because it's just intersects with I've already OR'd these opponent, and I've already OR'd the black and white pieces on the board, but that's okay. Self that intersects with board or self that, lots of optimization kind of popping up. So I'll just write a to do here. To do, we have this set of occupied squares on the board instance. Simplify. And then so legal pawn move, if it's in a legal non-attack move and doesn't intersect. What's it upset about here? J expected? Oh, or expected. Let's do this really quickly. Oh, it's en passant move. No, this should work. What's it upset about here? I'm just so confused. Oh, I see. I'm missing a square bracket. Okay. So legal non-attack moves, I need to intersect with. Alvaro says, can you also exclude your own pieces, Bitboard, as you go? Yeah, I need to exclude own pieces for pawns. For any piece as well. Legal pawn moves are going to be I OR'd with a complement of, no, wait, slow down. So it's every legal, quote unquote legal non-attack move that's not also in the set of occupied squares. So is that just an and complement? Yes. Yes. So we take the complement of the occupied squares which would be all the empty squares, and then if all the empty squares are, any empty square is a legal pawn motion move, then we're good. So we can legal non-attack moves and or the and equals the complement of the self.board.empty squares. So I don't even need to use the that's cool. I don't even need to use the so basically I've already simplified that. So I believe that for pawns, legal pawn moves are the following. Basically, pawn motion that don't intersect, pawn non-attacks that don't intersect with occupied squares, pawn attacks that do intersect with opponent pieces. The proposed move, an empty bitboard. Turn bool is a legal pawn move. Alright, so let's review this really quickly. I should just write a test. Maybe next stream I'll write some tests. Alright, so we have the square that we want to move to. The legal non-attack moves before checking intersection is the white pawn motion or black pawn motion bitboards. The legal non-attack moves should be I-anded with the empty squares, not the complement of the empty squares, but the complement of the occupied squares. So and or this with the and or I keep saying I and this with the empty squares bitboard. That should filter out occupied squares. Then the legal attack moves are the white pawn attacks and the black pawn attacks. We have the opponent occupied squares. And so then we I or this with the opponent occupied to see if those legal attack moves actually attack an opponent square. So that should filter those out. Shouldn't this be and or? This should be and or. I keep saying and or, I and. Yeah, we need to intersect with the opponent occupied squares. En passant bitboard is then an empty bitboard set with the en passant target. So now we do legal attack moves on our moves or the en passant bitboard. No, and the en passant bitboard. Legal moves are then the union of all of these. The legal attack moves, legal non-attack moves, and the en passant move. There's only ever one en passant move per move, obviously, because there's one target square. There could be more than one en passant move per position because two pawns could attack the same target square, but per piece there's one. Only thing missing now is promotion. Yeah, that's actually a really good point, I guess, but you should maybe do that after the pseudo-legal moves along with the real moves. Why not attacks is and equal, but attack is or equals with opponent. Yeah, I think I fixed that. So we can only attack where it intersects with an opponent for a pawn. Okay. So now, yeah, excluding promotions. So our pawns can legally move to their ultimate square, whether it's in the H or the A file, but I'm not handling the logic to then promote at this point. So that will be to do. I can actually, since we're doing all this mutation, where was I mutating self.move? Where I said I was pretty sure I was going to be introducing a bug. Here, move.isCapture. So what I could do is at the bottom of this, I could mutate the move. Rather than return true or false, I could mutate it in place here. I hate all these side effects that I'm introducing with the move mutation. Yeah, that's not right. That's where a bug is going to be. If I'm mutating the move on the fly here, I guess when I call this function, I'm evaluating one move specifically. All right. Well, whether or not there's going to be a bug remains to be seen. I think all this is going to get rewritten anyway, but is captured true if move square bitboard and legal attack moves per self.to-move, it's a capture. And if move square bitboard is in so much junk in this one. This would be self dot promotion rank. Color dot white is going to be self dot board dot, or it's just going to be rank dot hex8. And black, it's going to be rank hex1. And these are already wrapped in Numpy constructors. So here we can say if move square BB and non-legal attack moves, or legal attack moves is what I need to say here. And if move dot square BB and self dot promotion rank, not self dot promotion rank. Why did I do this? Row motion, promotion rank, then move dot is promotion is true. So I'm going to put a to do up here as well. To do possible side effects from mutating move all over the place in move legality checking. All right, but that's pawn moves. So basically, get the square that we're moving to, get the pawn's legal attack moves by side, and equals that with the empty squares bitboard. That tells us if we can move to that square, then handle the attack moves, in which case we need to, I'm going to move this down to where it's a little bit more useful. Get the attack moves. We need to intersect that with the occupied squares to get the truly legal attack moves. Then we handle en passant by getting an en passant bitboard, which is just a bitboard containing the en passant target. Probably... Okay, that's fine. How is this gonna work? I may have to... There may be a bug here. This is just a number. Is that gonna work? Anyway, that should work. Promotion rank depends on whether you're white or black. And if the move square bitboard intersects with the promotion rank, then it is a promotion. Then we return legal moves intersected with the move square bitboard. Do I need to intersect that again? Yeah, it's the move that we're trying to move to. I'm going to rename this to moving to square. Okay. Last thing I want to do for the moment is to pull this back into Jupyter if possible. And when we're making the move, where's our make move function? We should see if it's an illegal move now. I anticipate there should be some bugs, but let's give it a shot. Can come back to the game position notes. We'll shut down this notebook. We blew up somewhere. Unsupported types, dictionary and int. Legal non-attack moves. This is on 143 in position. Oh, I see. Legal non-attack moves. We need to do self dot to move. A lot of that could probably be extracted to make it a little more easy to read as well. Alright, so we blew up somewhere else now. This is on... Oh, wait. Still blowing up in the same place. Dict and int. Is this a dictionary? Must be. Yep. Here we need to look it up by the move.toSquare. Actually, this is the move.fromSquare. Yeah, no problem, Alvaro. Getting pretty close, I think, to initial legal move generation where we'll actually have a chessboard to mess with. I think the real difficulty is, this is kind of like grunt work. I mean, it's an interesting puzzle, but I feel like the real work will go into search and realizing probably how inefficient what I've written is. All right, white pawn, attack bitboards from move dot from square. Alright, so we're blowing up on this one. Int argument must be a string, not none type. So we're passing none now on line 75 in Bitboard helpers coming from position on the en passant Bitboard. Alright, so we got further down, en passant target. Here we're just going to say if self.en passant target. Then we handle all of the en passant stuff. And then here, this is super inefficient, but sorry for all this, the hacky stuff, but I'm going to do if self.enpassant target here again. Yeah, definitely have to cross that bridge when we get there. All right, so if we move this up here, so what did I jack up here? Hold on. We'll say if en passant move, we do this. If self.enpassant target. But legal moves up here. And we do this, this, and then we legal moves I or en passant move that was just calculated. Okay, it's a little bit happier now. I think that's right. All right, so we fixed that little bug. Now if I make an illegal move, I'll be interested to see if it actually works. I have a feeling there'll be some bugs, but all right, so we got white pieces, we got black pieces, all that still works. So we're gonna make a move from E7 to E5. Look at that, illegal move. Why? Have I not made it? Oh, everything's coming back as an illegal move right now. That's funny. Is the Bitboard's not getting updated either? Well, that's good. It's just that it thinks every move's an illegal move right now. But it's not bugging out beyond that. So it's actually preventing us from making a move. That's good. We need to figure out why it's an illegal move. So for pawns, let's see if knight moves are illegal. So we're going to start up here. Let's actually start over one more time. Print BB, hex, hex, hex. So let's move a white knight from G1 to F3. All right, so it thinks everything's an illegal move at the moment. We can fix that though, that's no problem. Okay, I'll be right back. Okay, let's get back at this for a little while. So basically I gotta figure out this bug where it thinks every move is illegal. That's better than every move is legal. Yeah, Alvaro, right now we are in the safe side. Things will be a lot harder once we get to search, actually. Okay. So let's figure this out. Right here I'm gonna say print legal moves. It's not even getting there. Oh yeah, here we go. All right, so there's this. Let's go ahead and insert a cell below or above, it doesn't really matter. Pprint bb on this. Isn't that the wrong direction? Black pawn on e7 should not be going north. And it's also not including its motion moves. It looks like it's including its attack moves in the north direction. Let's see what happens when I try to move a knight first. Let's take this. Let's start from up here. Insert cell above. Move, make move. Let's just do white knight again from g1 to f3. And then pprint self.board dot position.board. Complement of empty squares because I can't find the other one immediately. So a knight move just says illegal. Let's go ahead and go back to the knight moves and print what it thinks the legal moves are there. This is what I get for not testing. First of all, does this work? So we'll go ahead and do when I move the knight, it doesn't even actually get to this, no? It doesn't, so let's figure this out. Is legal knight move for a move in a bitboard. That's because I did white king, black king instead of knight. So that's so far a typo. Still coming back as illegal move. So if move piece in white knight, black knight. We're going to put some debugging in here. Moving a knight. Should probably do this in a new notebook. That's interesting. This isn't even coming up as that. So here's what I'm going to do. I'll make a new notebook. If anyone wants to play chess, feel free to challenge me at Westman on Lichess. And I'd be happy to play a 5-minute game. So here's what I'm going to do. I'm going to bring everything into a new notebook here. This is going to be move legality notes. Come back over here. Just get the important stuff. Here things have become really nice and terse, so we can say like board dots occupied squares. Nice. May even make a helper function just to print the current occupied squares. But what we want to do is try to make moves, so I'm going to close this notebook. For this one, this is where we have our illegal move. So let's go back to the make move function, which is here in position. If not, self is legal move. Here we're going to print move dot dictionary print make move. So piece 3 from square 6 to square 21. So that's not right. Oh, maybe it is. It is right. All right, so 6 to 21. It's not a capture, it's not a promotion. Piece is 3, so let's look up piece dot white knight. That's 3, so that's correct. It just immediately comes back as is a legal move. Piece in white knight or print move dot piece print checking legality. Here we can just return false as the default. So I'm not hitting this. Checking legality, 3 illegal move immediately. So why don't I end up in here? If move that piece, does this not work? 3 in piece dot white knight. That should be true. Why am I not inside moving a knight? Move that piece is just an int. This isn't a special type. Move.piece is just piece, so that when I make the move, it's just a number. So the assertion passes. Oh, why does this not work? Oh my gosh, it's because it's just ORing a number. I think I've been spoiled by Numpy here and being able to do this, right? Maybe this doesn't work either. No, that doesn't work either. Basically, I just want to say I want to do this instead. Not an or, but a comma here. Because I'm an idiot. Okay, so that's the first reason why everything thanks Alvaro. Yeah, you caught it as well before I did. All right, so restart and run all. Okay, it's moving a knight. Now it still thinks it's an illegal move, but now it's going to be due to some deeper logic than the immediate check. So we're moving a knight. That's all good. We know we get here. Let's go into is legal. Legal moves is here. Let's take a look at what our legal moves are really quickly. Pprint, bb, this. Those look like legal moves for the knight. On f3. Oh, it's a move on g. I see. That's funny. So it's actually, no, yeah, it's good. G1 to f3. All right. So let's figure out what goes wrong. This legal move. Here we'll say that doesn't intersect with to move. Here we'll say intersects with own. So we'll see which one it thinks it is. So here it thinks it intersects with its own piece. Oh, because I said if not intersects with own. So we need to say if it intersects with its own pieces, return false. All right, so we have a legal move, and we have a somewhat legitimate check for knights now. So that's good. Let's try to move a pawn now. So if we do white pawn from e2 to e4, best by test. All right, and pawns move, so that's good. Let's take a look at the legal moves just to be sure that that looks legit. And that does look like the two legal moves for a pawn on e2 from the opening. So now we should also just double check that we want to move a pawn from e4 to e5. So that looks like it didn't update. Here's the legal moves. Oh, do I have to call update? I'm not sure that I updated the position. I don't think make move updates our position yet, so I need to call that. But Basically, I want to check to see if the legal move was correct. No, it tried to move the pawn backwards. Yeah, it tried to move the pawn backwards after the first move, which is funny that it didn't. So now we need to look at pawn motion. Intersects with own pieces. Yeah, I should clean this up eventually. I do call update bitboards actually, so we need to see why the pawn got messed up. If I move the knight twice, does that work? Maybe just one bug at a time, but if we try g1 to f3, should also check that it's illegal to do otherwise, to do an illegal move. So knight f3, then what if I want to do, say, knight f3 to g5? Okay, cool. Well, the knight is routing correctly, so we have a bug with the pawn motion. Let's start over, and if I wanted to say knight f3, and then let's say I wanted to go to g6, which should be an illegal move. We get a legal move, and I print. Oh, it looks like the position is also going back to the starting position, so 2 bugs. To do on a legal move, it looks like we're resetting to starting position, and then bug fix pawn motion after opening move. Right, I suspect it's after the first pawn move. So let's come down to pawn moves. Alright, so the moving 2 square legal non-attack moves is going to be this. White pawn motion bitboards is going to be this. So I should be able to do a lookup here on self.board.white pawn attack bitboards. So let's just take a look really quickly. Self.board. Sorry. Just board. So board dot white pawn attack bitboards at square.e4. Okay, that works. Pawn motion bitboards is what we're really looking at. So that's set up properly. So it's something in the move generation itself that's messed up. So after we check is a legal move for the white pawn, that returned true, right? Maybe I just don't have the pawn set up. Piece map, empty piece from the existing spot. Map piece start remove, put the piece in the new spot, update castling rights and non-passant targets. We can do that later. Update bitboards from the self.piece map. I have a feeling the piece map is updated correctly. If it's a white pawn, we need to set the white bitboard pawn map here. So let's run this one more time and try to figure out where the error is. We know white knights work for the time being. White pawn from e2 to e4. And that looks good. Now we go e4 to e5. And that doesn't work. 12 to 28, 28 to 36. That number is correct, but it actually says illegal move. Okay, I gotcha. That's why it doesn't update. And that's why the board stays the same, so that part's okay, I guess. So let's find out why it's an illegal pawn move. Oh, I am printing legal moves. All right, so what does it say the legal moves are here? Not getting to that point. If move piece in, you have made a legal knight move. Oh, yeah. Thanks, Alvaro. Also, you're right. Good catch. Thank you for that. Good catch as usual. Hopefully this one works. All right, so we're still getting an illegal move, but it thinks now we can actually debug it thanks to your help. We're going to insert the cell below here. We're just going to p-print the moves it thinks that it can make. It's this. So it thinks that it can only move backwards 1 square. So it's seeing its legal moves as 1 square backwards. So we got a calculation error somewhere. We know that the static bitboard is set up correctly because we just checked that. So let's figure this out. So legal moves originally get set here with legal non-attack moves. All right, so here's what I'm going to do is say, wait, self.toMove. And that's this. We're white. We're going to get the pawn motion bitboards. We're and equaling this with board.empty_squares bitboard. Legal non-attack moves. Alright, so here's what I'm going to do is print this. Legal non-attack moves is this. And then, so we know that the static bitboard itself looks correct. So let's rerun this one again. Wish you could collapse cells in Jupyter. All right, so legal non-attack moves are for white and black. So let's p-print BB for white. Okay, it sees that this is the legal non-attack move, which is correct. Occupied, legal attack moves. Legal moves is now equal to legal non-attack moves or legal attack moves. So let's print legal moves, which should be the same. There are no white pawns that attack anything. Okay, so now this is where it gets jacked up because it thinks that the legal moves are now behind it. So here we can do legal non-attack. Moves is going to be legal non-attack moves. Legal attack moves should be empty. All right, so legal non-attack moves is correct. Legal attack moves. Those are not legal attack moves, but maybe that's before I've done the intersection. So why don't those OR together then? Anyway. And that's not before I've done the intersection, by the way. So I have to think about this for a moment. Oh, wait, I'm indexing into this. Yeah, I'm indexing into this. Okay, so all right, so let's manually interpret this. Legal attack moves is 0, so that's true. Oh, is this not getting cast back to legal attack moves, self-copy, bitboards? Are these not going in as Numpy arrays? No, they should be. They should be. Just to be sure. One question is with the to move or with the from square. Oh yeah, that's a good point. Let's see. That's a good point. All right, so let's check that really quickly. So to move is the side to move. And from square is the position that we're moving from. Legal attack moves for the side to move and equals the opponent's occupied with the side to move. That looks correct. So legal moves is the legal non-attack moves. Yeah, you're right. Maybe it's this. legal non-attack moves here for the self.from square. Move.from square with the legal attack moves. What's the legal non-attack moves? Oh no, my bad. Hold on. No, this was correct. Ay, ay, ay. Legal non-attack moves with the legal attack moves. And we saw that legal attack moves is 0. Legal non-attack moves is this. Oh, so it's like this is going backwards for some reason. So which one's going backwards? The legal non-attack moves is going backwards by the time it's printed here. Legal non-attack moves. So legal non-attack moves is this. We print legal non-attack moves here. So I'm going to do this first, see where it gets updated. Yeah, so it's actually messed up here. So legal attack moves. So it must be getting messed up when we and equals the empty board squares. No, it happens even before that. White pawn motion bitboards. Moving 2 square. So legal pawn moves from. Should probably clean up some of this. Legal pawn moves from 28. Yeah, that's correct. How is this different? We just look it up and then why is it different? So we're going to get rid of all these prints. So if self.board.white pawn motion BB's from square is the correct value, where does it get mutated then? It's correct here and then all of a sudden it changes in the very next one. So how can it be different before it goes into the dictionary and then when we get it out of the dictionary? I must be missing something obvious here. We put it into the dictionary and it is this value. And then we get it out of the dictionary and it's this value. So what did I mess up here? Oh. No, that's the from square. Let's just print the non-attack moves again. And figure out what's messed up here. Oh, it's the other value? Yeah, is the dictionary backwards? It's saying that this is correct. Does the side to move get updated somewhere? Saying white to move. Oh, this whole time I'm a complete idiot. I'm an idiot. I haven't disallowed white to move twice. I'm just moving white twice and to move gets flipped the second time I'm running it. Gosh. I need to put if not side to move return false. Oh my gosh, I wasted so much time on that. Oof, that was embarrassing. All right, so in make move, so is legal move needs to first of all check to whether or not it's the person's correct side to move. So the dictionary was fine, but it's just I'm going to say if not self dot to move is equal to move dot. Okay. So let's go to constants. Right? That's rough. So I need to say if we need to make a dictionary of color to pieces for the purpose of the piece to move. So we'll go back to constants. Don't try to move the same piece twice, or don't try to move the same color twice when you're building a chess engine. It shouldn't allow you to do that. All right, so what we'll do is we'll say class piece property def is. I'm glad we both didn't think of it, Abra. Is white piece. Whatever. Where do I want to put this constant? Property def white pieces return. Doesn't need to be a property. Try to keep my font a little bit bigger. Hey, Bikwa. All right, so the simple sort of hacky check here would be if self.toMove is color.white and move.piece not in piece dot white pieces, return false. Self.move.color.black, move.piece not in piece.black pieces, return false. Be a lot of optimization all over the place here, but and probably want to rig up some debugging soon actually too, or some logging, I mean, for the purposes of debugging. So now at the very least we should see that it's not white's turn, it's not black's turn or whatever. It's not black's turn. Yeah, the turn's been updated at this point, so it's not that it's not black's turn, it's self.move.color. Yeah, so it should be the other way around. Really, more explicitly here is, I should say that isn't one of your pieces. Why didn't I choose .NET for this stack? I just felt like doing Python for this. I figured it'd be a little bit faster, plus I like working with Numpy. And I thought that the Numpy would provide a good data type for this. Obviously .NET would as well for the Bitboard representation. I may rewrite it in .NET. And yeah, Alvaro, it was the other way around, thanks. Basically, if we run this. So if we try to move a white piece again after we just moved it, it'll say that's not one of your pieces. But if we try to say move a black pawn from E5, or sorry, E7 to E5. Yeah, exactly. All right, so it looks like the black pawn didn't actually move properly. Did the position switch? So if I try to move black again. All right, so now something's a little bit messed up. But I think I'm going to leave it here for today. So the next thing that we need to do is to wire it up so that move legality checking looks like it's kind of messed up the flow of our game. So 2 things for next time are G1. All right, so that's working. 2 things for next time are sliding piece legality checking, as well as pawns still aren't. Bishops clearly aren't working, and pawn motion isn't wired up totally properly. Knights appear to be working though, and at least the static bitmaps for the other types are also working. So queens and